Hey, what's going on, guys? Let's do this problem right here. Here we have 100 degrees Celsius connected to 0 degrees Celsius, and we have a bar right here that is made of copper and aluminium. Copper bar is 0.6 meter length and aluminium bar is 1.2 meter length, and the question is asking for junction temperature and heat transfer rate. Now let's see how we can find that one out. So the key information we have to know is we have to know that when we have this heat transfer in series, it's going to be equal everywhere. So heat transfer for copper and heat transfer for aluminium is going to be equal. So that's the thing we have to know in order to solve this problem. Now let's go ahead and solve it. And we know that this is a conduction reaction, right? Conduction process, I mean. So conduction process, we use this equation to find heat transfer. That is Q dot is equal to Ka delta T, right? Delta T over L. Now we know that when the heat transfer in series, it's equal. So heat transfer, we can equate heat transfer for copper and heat transfer for aluminium. Now let's create heat transfer equation for both of them, right? So let's create the heat transfer equation for copper first. For copper, it's going to be KCU, ACU, and delta TCU over LCU. And for aluminium, it's going to be the same thing, KAL, AAL, delta TAL over LAL. And if you notice, the length of the aluminium is double of length of this copper because 0.6, 1.2. Now instead of writing LAL, I can write 2 LCU. So let's write this one as 2 LCU. In that way we can cancel some of the things, right? From this one we can cancel this one, this one and this one can be cancelled, and also cross-sectional area for both of them is going to be same, right? 10 centimeters square. For this one also is going to be 10 centimeters square. So we can cancel that one too. Now we are left with this part. Also we have a 2 right here, and if I bring this one to the other side, that's going to be 2 KCU delta TCU is equal to KAL, and we know the KCU value that's provided, KAL value that's provided, delta TCU, that's what we are trying to find, but delta TAL, if we have two unknown variable, we cannot find it, but we can write delta TAL as 100 minus delta TCU, right? The temperature difference at TCU minus 100, that's going to give us delta TAL. Now we have only one unknown variable. Now we can solve this one, right? Now let's go ahead and plug the values and see what we get. So first, let's continue this one right here. First we have 2, and thermal conductivity for copper is 385. So this is 385, and delta TCU, that's what we are trying to find. And that is equal to KAL, thermal conductivity of aluminium, that is 205, and we have 100 minus delta TCU. Now let's solve for delta TCU. Let's simplify this one. This is going to be 770 delta TCU is equal to 20500 minus 205 delta TCU, right? Now if you solve for delta TCU, you should get 21.03 degrees Celsius. Now this is delta TCU, but the question is asking for junction temperature, right? To find the junction temperature, all we have to do is simply subtract this delta TCU from 100. Tj is equal to 100 minus delta TCU, and 100 minus this value 21.03 degrees Celsius, and that's going to give us 78.97 degrees Celsius. Now we have the junction temperature. Now we can, by using this information, we can calculate Q dot. we can use this delta TCU, because in order to solve this one we have to know one of the delta T and K and area, right? KA already we have that one, and length also there. Delta TCU is there. So let's go ahead and calculate for copper. If we calculate for copper, that's going to be same for everything, because we know that heat transfer in series is equal everywhere. So if we calculate one of the thing, that's enough, right? Now let's go ahead and do the calculation. So we know that Q dot is equal to Ka delta T over L. So Q dot Cu is equal to Kcu ACu delta TCu over LCu, right? Kcu is 385. Maybe I continue this one right here. We don't have enough space right here. Okay, so let's continue with this equation. Q dot Cu is equal to Kcu ACu delta TCu over LCu, right? Kcu is 385, and then ACu is 0.001 meter square times delta TCu. That's what we calculate right here. That is 21.03 over length of copper is 0.6, and if you calculate this one you should get 13.49 watts, and that's gonna be the final answer. I hope you guys find this video helpful. See you next time.